The next distribution technique is binomial distribution. What is this binomial distribution? Let us understand. The binomial distribution would calculate the probability of the successes in a fixed number of trials, where each trial is going to produce only two results, either is positive or negative, success or failure. Now, by using a simple example, we are going to make it very clear with this binomial distribution. Here understand, before we get into the details, let us understand the key points. The number of trials will be fixed here, that is n. For example, we just are going to flip the coin for 10 times. Out of this 10 times, in every time when you flip the coin, there will only be two possible outcomes. Either it could be head or a tail. There will only be two possible outcomes, success or a failure. But what is success or failure depends on what exactly you call. You call head or a tail. If you call head and result is head, meaning it's success. If you call tail, result is tail, meaning that is success. But anyhow, here in this case, we are going to take head as success. To exemplify this, we are going to take head as success, tail as failure. Okay. Now, constant probability P. Now, every time when you flip the coin, the outcome is 50%. Outcome of, let us say, the probability of getting head every time is only 50%. It is as equal to as the other outcome, which is tails, right? Now, one more thing is, the result of consecutive trials will not be dependent on each other. For an example, in the first instance, I got head. That doesn't mean that it is going to contribute towards my next instance success, right? Either the next instance success, either the next instance is going to produce a success or failure is not going to be dependent on the previous instance success or a failure. So, every time when there is an outcome that is independent, right now I got head. Next, what is going to come is not related to the current outcome. Okay, that is what we just need to remember with respect to constant probability. Constant probability is just 50%. Right now it is 50%. Next time also it is 50%. There is no relationship between each trial. It's independent of trials. Now, let us example. Let's say you flip the coin for 5 times. So, the number of trials is equal to 5. And you want 3 heads there. If you get 3 heads out of these 5 trials, you are going to win. Exactly, you just need to get only 3. Neither more nor less. You just are playing with your friend. Here, you bet that you will exactly get 3 heads. There are several parameters to be considered. We just need to calculate the probability of getting exactly 3 heads. If you want to get 3 heads, there should be 2 tails also, right? If you want to get 3 successes, there should be 2 failures also. Now let us understand the terms involved in this. Where n is equal to 5, you flip the coin for the 5 times. This is the total number of times that you're going to flip the coin. These are the total number of trials. P is equal to 0.5. Probability of getting head is 0.5. Every time it will be 0.5 and there is no relationship between the results. And the second thing, you want to find the probability of 3 heads. Now let us understand. Formula for binomial distribution. Here, P of x is equal to k. The probability of x is equal to k. What is the k here? K is 3. K value is equal to 3. For thrice, I want success, meaning I want the result to be head. P of x is equal to k is equal to n choose k into p power k into 1 minus p power n minus k. Once again, you just need to understand this formula. P of x is equal to k is equal to n choose k into p power k into 1 minus p power n minus k. Not a big deal. We will understand each term clearly. Now here, n choose k. What is this n choose k? N choose k meaning I want 3 heads. I don't want this to be continuous. It may be first 3 heads or the last 3 heads or any heads, rather any successes with any intervals. I want 3 heads. Understand carefully. These 3 heads may not be continuous, right? First one, second one, third one. First trial, second trial, third trial are the least consecutive trials, or in any trials. eventually you should be able to get 3 heads. In which direction, in which possible way, it is immaterial. But this n choose k is going to give you all the permutation and combination through which you are going to get 3 hits. Maybe the first sequence or the final sequence, or any sequence which has some intervals. The next thing is p power k is the probability of getting exactly k successes, 3 successes. The probability, this is going to give you the probability of getting exactly 3 successes. If you have to get 3 successes, as I already told you, there has to be 2 failures, right? That is what? 1 minus p power n minus k is going to give you the probability of getting n minus k failures, that is 2 failures. If you want to get 3 successes, there has to be 2 failures, right? For our flip coin, we want to have k is equal to 3. If p of x is equal to 3 is equal to 5 choose 3 into 0.5 cube into 0.5 minus 5 minus 3. When you substitute the values, n choose k, 5 choose 3 into what is p? Probability is 0.5, that is 50%, right? Into p power n minus k. N is equal to 5 and 3 is k. Okay. So then, when you substitute the values, it will be 5 choose 3 into 0.5 power 5. Now, how 5 choose 3 will get calculated? 5 choose 3 will be calculated as 5 factorial divided by 3 factorial into 5 minus 3 factorial. 5 choose 3 will be calculated as 5 factorial divided by 3 factorial into 5 minus 3 factorial. If you get it, if you simplify it, it will be 5 into 4 divided by 2 into 1, which is equal to 10. This is the value of 5 choose 3. Okay, 5 choose 3 value is equal to 10. When you substitute this, the total equation becomes 10 into 0.5 power 5, which is equal to 0.3125. Okay, that means the success, rather the percentage of getting 3 heads in 5 flips is equal to 31%. 31.25% precisely. This is how binomial distribution is going to get calculated. Thank you so much.